Hello everyone, this is Edionic. In this tutorial we are going to study how to plot a Bode plot. A Bode plot is a frequency response that we plot on a semi-log graph. A Bode plot mainly consists of two different plots, that is the magnitude that is represented by A versus log omega, that is frequency. Omega is frequency plot, and also there is also the phase angle phi versus log omega plot. So when we say Bode plot, we have to plot these two plots and find the other parameters such as gain margin, phase margin, etc. We also get other information from Bode plot that we will discuss later. If I say all the steps of drawing a Bode plot directly, you would not understand anything. So I thought I would discuss a simple and common problem, simple example, so as to understand the Bode plot easily. So let's check out the first problem that we are going to do. You might find the same example listed in your textbook as well. That's because it's a very common and simple example. So this is our question. Draw the Bode plot of the transfer function k s square divided by 1 plus 0.2s into 1 plus 0.02s. So this is our transfer function and we have to plot the Bode plot of this transfer function. So let's get right into it. The very first step is to write the frequency response, that is substitute s equal to j omega in this equation, that is g of j omega we have to write, that is equal to k of j omega squared divided by 1 plus 0.2 j omega into 1 plus 0.02 j omega. So this is our frequency response. We obtain a graphical representation of this equation in magnitude as well as phase angle with respect to log of the omega, that is frequency, using some steps. So the next step is we obtain a table comprising of these four columns, that is first is the term. We have different terms in this equation that I will come to it in quickly. So corner frequencies and slope, which is decibel per decade. What is decade I will show in the semi-log graph, and the change in slope. So these are the four columns. So what to write in these columns? So looking at this equation, we can see that there are three different terms. That is, the first term is j omega square. Here note one point: if we have k in our equation, we normally take it as 1 and draw the Bode plot. We have other methods to find k, but we are not mostly using it in your examinations and all. We just take it as k as equal to 1, otherwise they would give the value of k directly. Also, one other thing, if we have k or k j omega raised to n or k by j omega raised to n terms in our equation, write it as the first term here. Okay, so that's clear. So the next term is 1 by, always note that there is a 1 by 1 plus 0.2 j omega. If you do not put this 1 by, it would be an entirely different equation. And the third term is 1 by 1 plus 0.02 j omega. Alright, now we have to find the corner frequency, slope and change in slope with respect to these terms. The first term, that is these three forms, that is here it is j omega squared, we will just put it as hyphen, nothing, no corner frequencies are mentioned in for this term. For the next term, we will name it as omega 1, which is our first, or the corner frequency with respect to our second term, that is 1 by this constant, that is 0.2. Also, one point I forgot to mention, you have to make the equation here in standard form, that is 1 plus st1 form, all the terms. That is, you have to obtain this 1 plus, and that is very important. Otherwise, you cannot directly substitute like this 1 by 0.2 here. So obtain the equation in 1 plus st1 form, and the omega you can obtain by 1 by t1. Okay, and this can be easily calculated as 5. Now omega 2 for the next term is 1 by 0.02. You do not need a calculator for that, so it is 50. Now we have to calculate the slopes. For the slopes, first check whether the term is in the numerator or the denominator. If it is a numerator, put a positive sign. Here these two are in the denominator, so negative signs. And if it has a power, if it has no power, write as 20, and if it is raised to some value, multiply it with that value. Here it is the omega squared, so I multiply it with 2 and we get plus 40 here. Here it is raised to only 1. Never mind that negative 1, as we are already putting this negative here. So here it is taken as 1 and is 20 into 1, that is minus 20. Similarly here also it is minus 20. It's clear? Now let's find out the change in slope. The first term is change in slope is 40, so it has no reference value above. So here for the second one, it is this plus this value, that is minus 20 plus the above change in slope, that is 20. Okay, and for the next one, similarly, we can obtain this, just add these two to get the change in slope, which will get us 0. So this is our second step. Obtain this table and write all these numbers correctly so that we can move on to our third step. For the third step, we have these two frequencies right here. Omega 1 is 5 and omega 2 is 50. We have obtained that from the table. Okay, now moving that aside, we have omega 2 and you can write a less than symbol here, that is 5 is less than 50. Now we have to obtain two more frequencies, that is the cornermost frequency, that is omega L and as well as omega h. As you may know this, just take two random frequencies, and the only thing here is that for this omega L it should be less than omega 1, and for omega h it should be greater than omega 2. Here I can take 100, 75, anything I like. So here I take as 100 for convenience, and here omega L you can write 0.51 anything, so I take it as 0.5. Okay, that's clear. Now for drawing the magnitude plot, we have to obtain the magnitudes at all these frequencies, that is omega. Let me draw another table here. As I told you, magnitude is represented by A. So here 0.5, 5, 50 and 100. For the magnitude for the first two frequencies, that is omega L and omega 1, the equation is 20 log j omega squared. Okay, and omega here is 0.5, and here also the same equation should be applied. These steps you have to remember. Okay, now for this it is 20 log omega square, and here 20 log omega squared, that is 20 log 0.5 squared and 20 log 5 squared. This is a logarithm with base 10, so by using a calculator you can easily find out that is 20 log 0.5 squared, which is minus 12.04. that is, I can write it as minus 12 decibels. Okay, similarly I can obtain this value as approximately minus 28 decibels. Oh, sorry, I'm extremely sorry about this. This is a positive 28 dB. You can check it with your calculator. And for the next two frequencies, omega 2 and omega h, the formula is a bit different. Okay, so you have to study it like this. That is, here it is change in slope from omega 1 to omega 2 into log omega 2 by omega 1 plus the previous magnitude that we have already calculated. So here it can be we can obtain that from our previous table. Here it is from omega 1 to omega 2, change in slope is 20. So here 20 into log of omega 2 by omega 1, that is, what is our omega 2, that is 50 by 5, okay, plus 28. If you calculate this, you will get a value of approximately 48 decibels. And again, for the next frequency also, here we have change in slope from omega h to, sorry, omega 2 to omega h into log omega h by omega 2 plus the previous frequency, sorry, magnitude. That is, we have 0 into log 100 by 50. This term will eventually be 0 plus 48, that is, we get 48 decibels as our next magnitude. So we got four different magnitudes for four omega values, so we can directly get the Bode plot. So before going into that semi-log graph, we will quickly find out the phase angles as well for these, for some frequencies. So for the phase angle, let me write down our question once more. All right, this was our frequency response, and here I took k as 1. So for phi, the phase angle, we have, since this term is in the numerator, we get a positive angle for that. And for j omega, the angle is tan inverse omega by 0, that is tan inverse infinity, that is 90 degrees. So j omega square will be 90 plus 90, okay, that is 180 degrees. So plus 180 degrees for this term. And for the next two terms, they are negative, that is it is in the denominator, so the phase angle becomes negative corresponding to that. So tan inverse 0.2 omega by 1, and next term tan inverse 0.02 omega by 1. Okay, this is our phi. For omega, values ranging from 0.515, take some value. So again, like when we are plotting a graph, normally we take some values to get these points so that we can connect these points. So here I am taking some points for omega, and for the phase we can calculate by putting this in equation number 1 directly. So here it is 180 minus tan inverse 0.2 into 0.5 minus tan inverse 0.02 into 0.5, which will give us a value 173.71 degrees. Similarly, by substituting 1 in this and 5, 50 and 100 in this equation number 1, we get the angles corresponding to that. I'll just quickly write down these angles. For the first one, it is approximately 174 degrees. Alright, for the next, it is write down here 168 degrees. These are just approximately to a value, so you can plot it in the graph. And for the next one, it is 130 degrees. For you can calculate it right now in your with your calculator. Just pause the video and calculate these values. For 10 omega value 10, we get 106 degree. For angle 50, we get 50 degrees, and for omega equal to 100, we get 30 degrees. So these are we obtained 6 angles to plot the phase log omega plot. So next thing we require is a semi-log graph to plot the magnitude as well as the phase plot. So I got a semi-log graph here, and this graph, as you can see, is divided in such a way that here this region starts from 1 and ends here. Again, these are decades. 1 to 9 part is a decade, so these are divided into decades right here. So in this axis we will mark omega. Okay, omega. So while plotting, we will take the first region as 0.1. Okay, first point as 0.1. It starts from 0.1, and here we mark 1, and here 10, and so on. So it's not like our ordinary graph. So also these points correspondingly will be 0.2, 0.3, 0.4, here it will be 0.5. Okay, 0.5, we require the 0.5, so here it is 0.5. Then we require 5 here. It starts from 1, so 1, 2, 3, 4, 5. This is 0.5, and this is 10 we require. Then 10, 20, 30, 40, like that we get 50 here. 20, 30, 40, sorry, extremely sorry about that. 1, so 0.1, 0.2, 0.3, 0.4, 0.5. This is 0.5. Okay, not this point. I've taken the graph in the opposite direction. Okay, that's why I'm gone wrong. Here it is 5 itself, here it is 50. Okay, and 100 is this point right here. Okay, now to mark the magnitude plot first. So here I will consider the magnitude plot here in the top region. That is, if I draw a line here, and the values we require is here 48 to -12. So here let me mark 50, 40. This scale is ordinary scale, that is not in logarithmic dimensions. So just marking it like this. All these are in decibels, and all these are magnitude values. So for 0, I'll draw a line. Perfect. So then we just got to mark these points which we have already found out. It is for corresponding to 0.5, we'll mark -12 dB. -12 will be somewhere around here, and corresponding to 0.5, I mark it here. Okay, now for 5 we give plus 28 decibels. So 5 is here, and 28 would be somewhere around here. Okay, 5. Okay, now for 50 and 100 it's 48 decibels. For 50 it is 48. I'm just marking it roughly, just so that you can understand. Okay, you can do it more neatly. So or magnitude plot would be something like this. Just join this. All right, this is your magnitude plot. Now we are just going to mark the phase plot as well. So if I write this scale here, it will be somewhat crowded here, so to avoid the confusion I'm just marking the points here. So 30, 60, okay, 120, here we'll get 90, and I marked up to 180 because 174 is the highest angle we require. We have no negative angles here, so the plotting is relatively more convenient. Okay, so corresponding to 0.5, we have 174 degrees. Corresponding to 0.5, here it is somewhere around here. Okay, just a rough marking I'm making. Similarly for point 1, the point 1, we have 168. Okay, similarly I'm just plotting these points, so I just skip that part. I have plotted 4 points. For more beautiful graphs, you can take all these points. We have found out 6 points or more points. You can find out for any number of points. So I've just taken these 4 points for making this video shorter and saving your time. Just making sure that you understand this. So that is all about bot plot. I hope this video was informative, and practice with some more problems and you'll get the hang of it. So thank you, subscribe and stay connected with the community.